All right, everybody. We are getting into our next video on even odd functions. So I think that is page 22 in your note packet, so section 2.4. All right, so one major typo on this first page before I let you loose for a minute. First of all, I did not fill these in your notes. So the first function we're exploring is f of x equals x squared, and then we are exploring f of x equals x to the third in our second column. And down below, this is the big thing because I'm going to let you brainstorm for a few minutes on your own. This should say f of negative x. I'm pretty sure in your notes it says f of x. So f of negative x is what I'm asking you to find here. And then f of negative x, same thing here. So make sure you make those changes first. So what I'm going to ask you to do is just in a few minutes while I pause my video, I want you to fill in these two tables of values. And then what can you make out of this? What pattern can you find? What is f of negative x always equivalent to in this function? And then what is f of negative x always equivalent to in the f of x equals x cubed function? So I'm going to pause. I want you guys to think for a few minutes, and when we come back, we'll talk. So please pause now. All right, so let's look at this pattern. I know you guys can fill in these table of values. So the way I looked at this very first one, when you see what's really happening, I just plugged in some values for x. So the first one I let 2 equal x, right? So if I put 2 in for x, that makes this left-hand side of my equation f of negative 2. F of negative 2 is 4. So what else is equal to 4 on this table? F of positive 2. F of negative 3 is 9. What else gives me 9 as an output on this table? F of positive 3. I can do the same thing even if I flip-flop it, the negative and the positive. F of 1 is 1. The other thing that gives me 1 as an output on this table is f of negative 1. So basically, if I negate that x value, it really doesn't matter. It doesn't affect the output at all. So this first function, f of negative x, is always equivalent to f of positive x. All right, those are equivalent no matter what value of x I pick. F of negative 9 would be the same as f of 9. And something very similar happens here. So let's kind of do the same thing. F of negative 3. F of negative 3 is negative 27. But looking up top here, f of 3 doesn't give me negative 27. F of 3 gives me a positive 27. So what we have to do, if I want to kind of relate this in the same way, so f of 3 is close. But in order to make it exactly the same as f of negative 3, I have to make this part negative. So f of negative 3 is negative 27. F of positive 3 negated is also negative 27. So look at that pattern here. I'm changing the number from negative to positive. I'm changing the sign of what I'm doing, but I'm making kind of that outer part negative. I'm negating the output basically. So let's look at it for f of negative 2. F of negative 2 is negative 8. And to get negative 8 on the other side, using this kind of this same value, I can negate f of positive 2. And then same thing if I were to flip my numbers positive. Let's do f of positive 1. F of positive 1 is 1. So if I negate that sign, that gives me negative 1. If I kind of, I guess what I should say is if I'm mirroring it on the other side. So if I want to match up negative 3 and 3, or if I want to match up negative 2 and 2, or if I want to match up negative 1 and 1, what I need to do is take my output and negate it. So those are the main ideas we're going to be working with today. For this first function, x squared, f of negative x is equivalent to f of x. And over here, f of negative x is always equivalent to negative f of x. So if the sign of that input changes, it's basically saying, how do I keep the two functions equal? Okay, so let's take some notes on exactly what this means. All right. So this is all written in your notes. I have your packet here actually in front of me, so I'm making sure it all matches up. For a given function f, if f of negative x equals f of x for every number in the domain, then the function is called an even function. So kind of our classic example of an even function is f of x equals x squared. So watch how we kind of show this algebraically. I showed you on the first page with numbers, so I could plug in -2 here, and we would see that it would be the same as +2. But if I test this, if I say, okay, what is f of -x? There's my substitution. F of -x equals -x squared. -x squared is just equal to x squared. So algebraically, since it gives us the same answer, f of x is always, always, always equal to f of -x. So another really nice way to look at this is graphically. So the graph of an even function is always symmetric with respect to the y-axis. So it's basically a reflection over the y-axis. If I just graph my function for everything greater than or equal to 0, so if I were to graph just the first half on the positive side of x squared, I would get this. That was pretty sloppy. It's a little hard for me to do this on my tablet, so if you guys can do it better by hand, that's great. That's not bad. So there's f of x equals x squared just for the domain x is greater than or equal to 0. But if I just flip this, if I just mirror this over the x-axis, or I'm sorry, over the y-axis, it gives me the other half of this graph. So this is what it means to be an even function. It's perfectly symmetrical on either side of my y-axis. All right, so you can see right there, no matter what I plug in 2 or -2, it's giving me the same output. Same thing with 3 and -3, same thing with 9.5 and -9.5, whatever numbers we pick, it's going to give us the same output, whether our x value is positive or negative. So that's an even function. Okay, as always, pause, rewind if I went too quick anywhere for you. All right, odd functions, even odd. For a given function, if f of -x equals -f of x for every number in the domain, then the function is called an odd function. So this one's a little harder to wrap your head around. Sorry about that. What the heck? There we go. All right. But algebraically, we can show it the same way as we did the last one. So if I'm just testing this, if I want to see what happens when I do f of -x, so I plug -x in to my function, I sub it in. -x to the third power, -x times -x times -x is -x to the third. So the relationship here, these two aren't equal, but they're just kind of negated versions of each other. So you can see if f of -x is equivalent to -f of x. So in this case, -x cubed is the same as -x cubed, then this function is called an odd function. All right, so if f of -x, which would be -x cubed, is the same as, I'm sorry, I wrote that in the wrong spot. If f of -x, which is right here, is the same as -f of x, then it's an odd function. And there's symmetry happening with this one as well. So the graph of an odd function is symmetric about the origin. Symmetric about the origin. So by graphing the function for x greater than or equal to 0, you can obtain the entire graph by reflecting it through the origin. And if you think back to your geometry days, a reflection through the origin is the same thing as a 180 rotation. And to do that, you just negated the x and the y coordinates, which is actually exactly what we did up here. We negated the x, we negated the y to make these two things equivalent. So the best example of an odd function is x to the third. So I'm going to be way off my graph paper right away, but x to the third, just the part greater than or equal to 0, looks like this, and it's, it shoots up pretty quickly. All right, now if we just negate these both these coordinates, if we reflect this through the origin, 1, 1 becomes -1, -1. 2, 8 becomes -2, -8. And there we can see the reflection through the origin. Okay, so to look at it graphically this way, if I look at 2, 8 as one of my outputs, it matches up with -2, -8. So there's your reflection through the origin. So that's the way we're going to investigate odd functions. If f of -x equals negative f of x, then this function is an odd function. Okay, so there's the basics of it. We will wait to class next time to do some of these examples. It's a pretty short lesson, so we'll do some other stuff in class together next time I see you. But we'll try a few of these out. Let me know if you have questions, and I will talk to you guys soon. I think that's all I have. Yep, that's all I have. All right, so you have a video, a homework assignment that goes with this in your Google form. And yeah, that's all. I will see you guys next time.